say thank you, everyone, for being here and spending your time with us. But I also do want to just go ahead and jump straight in, and we wanted to do that by showing you the demo, which is freely accessible online. So you can look at it yourself, just go to our website, hit the try for free button, and then you get to explore the same thing that I'll show you today. So what I wanted to start with is the study graph. So the study graph basically shows how we turn code and logs into a queryable data structure, which is quite obviously a graph. So it contains all the information about the code and whichever metadata we have, as well as the data sets that you create in your process, the formats that you use, and even all the computations on individual variables. So as you can tell here from the graph, a single data set is represented as a node, and they're all connected somehow. And the way they're connected is, of course, that if one data set depends on one or more data sets, it's downstream of them. And if it is the source for, again, more data sets, then it is upstream of those. So if we're interested in this one, what the study graph shows you right now is the step itself that we extracted from the logs as a code representation, and the log messages that are associated with that step. So what you can do then is you can go through and you can see basically trace the origin and also the result of that data set. So you can tell here that this one we just selected, it is a merge of SDTM AE and ADSL, which is exactly what the graph shows. And you can follow it also downward. And if you pay attention a little bit to the step up here, it has in parentheses which file this was grabbed from. And as we transition, you'll see that the files change. So what that means is that we're creating this graph across the entire study, independent of which file it is in. So you really do have a full traceability throughout all files in the study. So due to a great amount of user feedback, this interface is going to change a little bit, just to make everything a bit smoother in terms of experience. And to give the code itself and the log messages a little bit more real estate on your screen. But the point here is that we want to show you what our traceability looks like on the dataset level, and understand that it's already useful as it is to understand how data flows through your study. So for example, if you onboard someone else into your study, or you're onboarding yourself into a new one, or you're sort of onboarding yourself to old code that you've written a while ago. And also, what's really useful, of course, is if you work on a specific data set, then it's quite nice here to visually trace what its origins are, so that you really understand what you're working with. And what it does, as you can probably tell, is it will show everything in white that is upstream, and everything that's sort of in gray that it affects, and everything that's sort of black is just, for this particular one, not relevant. So that's the study graph, visualizing the traceability. We have a second component, which is the validation overview. And it's really important to understand that this is, a very, very early version. And let's look at what it shows you on a file by file. So on the left, what you see is a set of steps, which are all the code steps that happen in that file. And if you get the green check mark next to it, that means that there are no log messages associated with it. So it's probably something you don't have to worry about. Whereas if there are some log messages, you will sort of get a count of the kind of log message. And we currently have 3 categories. And this is something, we'd love feedback on, is we have a big red one for errors, which of course have to be resolved. Then this orange is for warning and notes, which you obviously should look at. But, notes fall into really 2 categories. Sometimes they're very important, and sometimes they're not so important, depending on the context. And one of the main advantages that we have through the tracing ability and the code understanding is that we can actually classify them. So some notes which are important in one context are obviously not important in all contexts, and we should be able to tell the difference quite well. Another thing that we wanted to highlight is that we, as long as mprint is turned on during the execution of the code, we can resolve these macro calls. So as you can see, in this case, there's a macro called, and then in mprint, you see the individual steps. And if we look at any of these log messages, you get them nicely highlighted, but you also get an indication in which part of the resolved macro this log messages actually occurs. And so, for example, this proc step This one is this data step, but there are no log messages associated with it. And here at the bottom, we have another one associated with this final data step. So you always have a very clear indication of where the log messages belong. And the macro resolution, of course, in itself is already a feature, because what this means is that as long as you turn mprint on sort of in the right spots, you can generate macro resolved code, which is often required, of course, when you prepare your code for submission. So the main use of this is, of course, the macro resolution is one part of it, but it's the clear presentation of the code and the associated log messages, and that you can navigate this sort of in the classical way through code, but the graph itself is also in here. And I wanted to show one other thing, which is, so this basically shows the graph for the file, not the entire study. And you can see that even the steps that and the intermediate data sets that macros create are part of this graph. So it's not like as soon as we hit a macro, we go into this black box and we lose all traceability. As long as mprint is enabled, we parse these out, and they become part of this graph, of the execution graph. So this basically concludes the demo. It's as I said, it's free online. Just try it out, play around with it. We'd love to hear your feedback. Yeah, that's this part. So let's I have to get organized again. Okay, yeah. So let's zoom out for a moment from the demo of this very specific tool showing two very specific things, really. And that is that we want to tell everyone what kind of journey we are on with Verisian. And our overall mission is to make clinical trial analysis better, faster, and cheaper. And if you have any sort of corporate background, then of course this triangle is often said that you can't make two of these components of the triangle, improve them without making the other one worse. But before we talk about that in a little bit more detail, we want to specify what better really means. And so in this case, what we mean by better is that the decisions are made at sponsor and regulatory authorities as soon as the science is clear. We want the decisions to be based on high quality data and high quality code. And we want it to be clear that the assumptions and implementations are fully transparent to all parties involved in making this judgment. And so that brings us basically to this triangle I was just mentioning. And you can only attack all three components of this triangle if you really do something fundamentally different, because otherwise, if you stay in the same paradigm of working, then you can only, change two of these. So the quality we're going to improve by working on code, working on metadata, working on data, and ensuring quality and adherence to the statistical analysis plan. And when it comes to speed and cost, these are a little bit easier to understand, of course. So we're going to try to use as much automation as is possible, as much reuse as is possible, and as much AI assistance as is possible. So what's the core of what we're doing? Well, it's basically this full traceability that we just saw in the study graph. What it does is we can read all logs or code and create a graph out of it. And what this really means is that we turn code into a queryable data structure. So it's a little bit as if everything that happens in the study is in a database, and you can now just query it. So you can find all the data sets, all the variables, all the formats, all the code lists, and also how they interact. So which format is applied to which variable in which data set, and so on. And so the point really is that you can, now that you have this in this data structure, you can query it in many different ways. One was the traceability that is shown in the demo, where you take a data set of interest and you see everything that's upstream and you see everything that's downstream. And if you put it down to variable level, you could be working on modifying a single variable, and then we can basically give you a list of all downstream effects across the whole study that you might be having by modifying that variable. We call that edit in confidence. So that's sort of the traceability angle on it. But there are many other things that we can do with this abstraction. And that is, for example, extract derivation templates. So if we know exactly how an STTM variable was calculated, Well, we know that exactly because we can actually pull every single statement that created that variable, which lends itself then to building libraries of reusable components. The same way we can, basically the process that we use to do that is a great process to create data sets to do fine-tuning of large language models for generative AI, which is something that we're also already actively exploring. And furthermore, and maybe finally, just sort of as a thought, is that you can combine, you can not combine, you can compare different studies or different parts of different studies, which is very useful in many ways. One use case we'll look at a little bit later, but another one would be, for example, pooling the data from different studies. So our overall goal for the Verisian clinical platform is that we'll have 4 hubs. One is the Statistical Programming Hub, and that is aiming at building and validating study analysis using this full traceability and then graph-powered AI. The Medical Writing Hub will eventually try to generate as much of the documentation as possible, but first we would focus on first drafts of Module 2 and 5 of the ECTD. The Submission Hub will try to bundle all of these things that we create and give reviewers also access to this full traceability to understand your submission better and make everything more transparent, which should hopefully make the review faster. And sort of behind all of this will be a real-time hub, which gives you real-time overview of the data quality as the study progresses, metadata, the code and the code quality, what it does, analysis results. And we're aiming to do this both on an individual clinical trial level, but also on the entire portfolio of trials if you're a sponsor and you do many of them at once. So the focus will first be on the Statistical Programming Hub, and this is really important. Of course, we have this overall vision, but you have to start somewhere and you have to focus on something. And we focus on this because we think here we can create the most value the fastest. So the Statistical Programming Hub really has 3 components. One is the validation engine, and this is what the demo is about. It's sort of a first very small piece of the full validation engine as it will be in the end. There will also be a building engine, which, as I said, part of this analytics can extract SCTM derivations and ADAM derivations and also the later derivations. And these we can put in libraries and then reuse. Furthermore, the log analysis that we showed you, this can be done in real time if it's integrated in an environment where you also build your code and you actively program. So you get the feedback in real time. You don't have to do sort of the log analysis separately. And we'll be able to do this on code level, on log level, as we show in the demo, but also validate other pieces of the analysis. And finally, of course, we'll have an AI assistant for the resolution of these log messages. So that one will focus on explaining what the issue is, what the likely causes are, and then suggesting fixes. The building engine is really the other side of the medallion. So of course, once you extract a nice library of templates of deriving certain SCTM variables, you'll want to actually do that. And the engine is where you would use this library to then build new studies much faster. The full traceability in the building part is very useful because it gives you this edit and confidence feature, which means whenever you edit something or modify something, it shows you all the things that you need to know which are upstream. And then as you make an edit or a change, no matter how big it is, basically it can provide you with a list of things that you have now affected. And of course, if you meant to do all these introduce all these downstream effects, and that's fine. But it just gives you that confidence that you can identify side effects that you didn't intend if you created them. And the AI engine for the build engine, again, will work very similarly, and that is it will help you build and enhance what you're already building. So it can help editing code. It can help showing weaknesses in the way something is structured, or even in detail how something is coded. So the focus on the validation engine at the beginning is because it will function as a gatekeeper. So it's basically going to be the quality control gate against which we develop all of the tools and all of the approaches that we have to attack speed and cost and basically efficiency. Because of course, in this industry and in this process, we cannot sacrifice quality and correctness just for speed and cost savings. So this is why the validation engine really comes first, because we need it to then develop everything else against, and always make sure that whatever we develop is of the highest quality and actually serves a purpose. So the more automated and proficient you are at quality control itself, the more you can then rely on automation and generative approaches sort of at the beginning of your creation pipeline. Because if you don't have the gatekeeper that makes sure that these things are actually correct, you don't actually speed up by generating things. It's just that you move the bottleneck from creating new code, so to speak, to making sure that it's actually correct. So our approach is to have something that automates making sure that things are correct and as we expect, and representing our assumptions first, and then to build everything that speeds up the part that's generating them. So, but this is everything that we're doing sort of in my words. I would really like to hand it over to Sunil and hear how a true industry veteran looks at this, and he would like to share his view with all of us. So Sunil, if you'd like to take over.
Great. Thanks, Henning. Thanks for the demo and everything. So as can be seen from the demo, I think I'm hoping, I know I'm excited. I'm excited to partner with Henning and also Thomas on this because I think this approach is very much a paradigm shift of what we've done before throughout the decades. This is important, and we've done various levels of these types of checks before with best practices and leveraging metadata. With a tool such as being described here in this demo, what we're looking at is really taking us, to the next level, automating things so that programs are being read. So just like I think the analogy that Henning mentioned is basically converting the SAS programs and log into information that can be queried. And I think that's extremely powerful. When we can do that, we have a lot of flexibility as programmers. We know what we can do as far as data management, data in, and doing analysis. But the key thing is with data management. So what I really like about this is it's reading the programs. So the SAS programs, the logs, and the sequence of the execution. With that as input, it can automatically track and resolve, needle in the haystack, as we're going through SAS log messages automatically for us. So we don't have to pull up individual SAS programs. We don't have to run a scan log, which many organizations, do. But, we're taking a look at a way to actually have the system designed to track and monitor these things for us. Not only that, with the demo, you can see that it's very easy to access. The other thing that I hope you're realizing from this is the ability to transform what we see as a program, meaning logic and things that are going on, the information that's being shared from one program to another, into a visualization process flowchart. That's extremely very useful, very popular. When SAS Enterprise Guide first came out, they introduced the process flowchart, which is really a nice feature because visually you can see how exactly what's going on. It's easy to explain. It's easy to review things with management, with statisticians and scientists. And what you have is when you have a tool such as this, you're really leveraging the technology to better manage, large volumes of studies and, more importantly, deliverables. So I'm really excited, to go through this and see what all is being capable. I think you can see the real benefits of this. Next slide, please. So what you have is improving your SAS programs. What you're kind of seeing is a glimpse of what's going on, which is what I consider to be SAS code log analyzer. So what we've been doing manually is now available in this type of tool where we can visualize and track data issues. We have three three paths. One is a raw to SDTMs, SDTMs to atoms, and then atoms to TLGs. So each of these paths are very important to make sure that there aren't any issues. So resolving each of those, so you can break these up into components, and you can visualize and track the issues. So that's really useful. Point and click process flow. I mean, who doesn't like being able to navigate very easily? You can see there's a lot of connectivity and traceability there. You can see what's going on as far as data being fed into the program. You can see the downstream. So I think the color really helps, so you can see exactly what's going on. Again, you can monitor the issues as far as the errors, warnings, and notes, which is extremely important. The other thing, as Hennings was mentioning, getting into impact analysis, correcting the code. I think that's also very exciting. From the demo, you can kind of see that in a separate program was kind of structured that has complete traceability that's pulled across from the other programs. That in itself is very, very difficult, if not impossible, to do manually. It's very time consuming. But with this tool technology and leveraging and again reading the SAS programs, generally in the past, best practices. Programs would read the SAS log and get information about it. This is really going to the next level, which in fact also is the last point, which is the demacrotized version of the program. So, with the mprint, mfile, everything, this is a way for us to have kind of the best of both worlds. We have programs, we have macros, and we execute them. The log files, resolves those, but there's not automatically a separate program. With this type of tool, we can actually see it's all integrated. And so that works very nicely. The next slide, please. So what happens is the bottom line is we end up improving our SAS code. We can now have a tool that helps us to better monitor and resolve two types of issues that can occur. One is the clinical study issues that are there, specifically primary, secondary endpoints, maybe data cutoff, AE count denominators. The things, beyond the error warnings and notes, we can target and know exactly what's going on. As Henning mentioned, the data set or the variable level, that's extremely powerful. In addition, we can also check things that are very important in many organizations, QC SOP, such as header information, other best practices. These are guidelines that the FUSE working group, which is made up of industry experts, are recommending. Now, these also, again, are many of the QC SOPs, but for the most part, they're a bit difficult to actually implement and definitely manually. With a tool such as this, you can take a look and you can go through for the programs that are being submitted. You can make sure everything is being addressed in many of these issues that may typically happen when you're taking a look at program issues. So bottom line is I'm really excited with things that this tool can provide. And as you can see, there's breadcrumbs. We can see how well we got with this data that we have, and also we can see the final results that can be produced. So thank you. I'll turn it back over to Henning.
Yep. Thanks so much, Sunil. For time's sake, I would just sort of speed on and pick up sort of where I left off. So again, focusing on the log analysis, which is part of this validation engine. The next steps are these are some examples of them. So one is what I'm sort of calling causal chains right now, because I don't have a better name for it, but it's that when certain log messages, maybe that are downstream in the analysis, like these two, are related to one that probably causes this that is upstream. So one good example are missing values, where missing values created at one point can of course create more missing values depending on the code that's written there at other spots. And so because we have this traceability information, we can actually group log messages into groups and then suggest what will be a fix to sort of get rid of all of them, rather than you having to go through all of them and sort of work through them one by one. Another one that we're definitely going to look at is code analysis. So making sure that the code is robust, which means it can handle unexpected data, give suggestions there, scan for certain issues which are really well known, and this comes sort of as a mixture of what's already in best practices, published often in Fuse papers, but also what comes out of code analysis that's common in software engineering. Another part is UI updates, of course, of the demo. So we've got lots of feedback, which was great. So we're going to restructure the visualization of the graph. I mean, it's huge, especially for sort of non-demo but real studies. It's quite overwhelming. So we will pre-structure them into libraries, the dataset nodes, and into files, so that you sort of have different layers of views on the underlying connectivity. And another one is that we, of course, now that you have these log messages, it would be great to sort of have a review workflow. So what we'll do is that you can go do the log analysis, and then you will sort of get the list of issues, and they'll be filtered as best as we can, and we'll add the causal analysis. But then, of course, you still have to review it. So what you can do is basically go through all of them and say, this is relevant, this is not relevant. And if it's relevant, then, you know, in some way you have to fix it, and then at some point mark it resolved. So this is just covering the process of actually doing the log review and resolution. Now, for the validation engine, there are a lot of things that we can do with this traceability, but I wanted to highlight a couple of things which are which we think are most valuable at this point. And again, it would be great to get feedback on this. This is already based on feedback, but you know, more feedback is always better. So one of the things that I was mentioning before is that SCTM and ADAM and sort of ARM and S template extraction. So we can extract the code that creates a certain variable, because this is how we establish the traceability. And so on one hand, that allows us to create libraries for code reuse, but in the other sense, this is also some of the information that defined XMLs need to have. And so we can help automatically updating those and filling those. And then, so this one is what we've been talking about. Validation programming. Validation sounds like a duplication. It is not. I'll show you in a second. And then the AI assistant. I just want to quickly highlight where we're at that with that part. So for validation itself, again, we're talking about this extraction and reuse, and I just wanted to make it very explicit. So for example, if we have, again, a small example of a statistic at the end of an analysis, what we can, you know, we know all of the code, so we know the by variables, we know the where variables, the where conditions, we know exactly how the tables are set up, even the titles, where we have all that information. And so we can extract this as a template. And of course, the real ones will be much more complicated, but we can grab onto them and then extract them for reuse, or, for example, to autofill parts of the defined XML. And the same, this principle also applies to SCTM and ADAM. SAP validation is another one, of course, that would be sort of one of those dream scenarios. And we, of course, for that, the SAP needs to in some way be represented in a machine readable form. But then again, if you have a library of ARMs or TLFs that you can build and select, we can look and parse these again and make sure that the correct procedures are used, the correct by statements are used, etc. So this is another way of looking at what we can do with the queryable code. And a final one as a use case example, or almost final one as a use case example, is the validation of validation programming itself. So of course, the underlying assumption of validation programming is that if two people independently program the same thing, or get the same results rather, then the probability that the result is correct is much higher than if it's just one person. But what I just, the way I misspoke was basically given the answer. Of course, the assumption is that they actually program it differently. So of course, there are always cases where this is intentionally not done, which is basically fraud. But there are also these cases where people do program basically the same thing, at which point the validation program sort of becomes obsolete. We can really easily compare programs on various levels on very non-trivial levels. So we can not only just look at, you know, sort of plagiarism kind of thing, how much code is overlapping, but we can actually look at the structure of the analysis and then tell if they are significantly different or if they're basically doing the exact same thing. And finally, the AI component, I just want to give a quick example to make it concrete in the scope of the validation engine, which would One of the things the AI agent can do is explain log messages. And so what I mean by explain is basically tell you what are possible causes of this, or what are the most frequent causes, what are good ways of solving it, or how could you address it, and then even suggest how this could be resolved. And yes, I realize this is not an actual resolution of the problem. This is illustrative, but so it's just trying to show you that what these two components will do. And so finally, again, this is our end goal, but I do wanted to highlight again what we're focusing on right now, and that is basically the Statistical Programming Hub, because this is where we got most of the feedback. I think this is where this whole code understanding is most easily applicable. But at the same time, if there are people who really want to work on other parts of this, because for them in their environment, that is sort of the Lego brick that's missing and is hurting them the most, then of course we're very open to talk about that as well. Currently, we're focusing on the Statistical Programming Hub. If there's significant interest in other components, of course, that is always on the table to expand earlier than planned. And that basically concludes my part. I just wanted to tell everyone thanks again for spending time with us. I hope this was useful. We'd love to see you in our community. Again, completely free to join, obviously. We already have some great people there discussing details about the interfaces and so on. So yeah, with that, I'd say thank you very much, and I'd hand back to Thomas.
Excellent. I just realized that I was posting in the chat I made the rookie mistake of basically posting only to host and panelists, but these are the links for to join the community. The demo that Henning showed at the very beginning, again, that's completely free to use, and it's something we created in a couple of weeks, and we were very, very keen to just put it out there in public. There's still so much more development that's going to be done. So if you want to join us on the journey of building this, let us know, whether it's within the community, as a client, as a user, or just someone from the sidelines who gives advice. Let us know. We want to build this together with the community. And like I said in the beginning, we're going to be hosting a bunch of these webinars. We've got a podcast. We've already had 2 episodes online. Put the link in the chat as well. We are also planning a number of in-person events. The culmination of that is going to be our main conference, our main user and community conference at the end of next summer, which is going to be in 2024. More details to follow. Sign up to our newsletter and say hi to us and Sunil and Henning, of course. And so, Sunil, do you have any final comments you'd like to add to that before we wrap up?
Yeah, just basically, I hope programmers, lead programmers, associate directors, responsible for their team, whether it's source or QC programming, can see a great deal of potential in what's being offered over here. Anywhere we can have technology to advance standards and automation will definitely resolve in using fewer resources to accomplish more, which I think is a great objective. And not only that, you have not only the quality is there, but actually I think the quality is going to be better because with this type of tool, we're actually empowering the team and empowering management, as well as communicating the senior management that we can handle larger volumes of studies and more deliverables, mainly because we're able to leverage technology on our side based on experience that we have. So thanks everybody for participating, joining this webinar.
Awesome. So yeah, if you have any remaining questions, post them in the next 60. Well, Sri just posted a question. I think this one is for you, Henning. Could you expand on the tracking and visualization of data issues, if possible, with a demo or screenshot?
Yeah. So data issues, of course, is a big topic. So I'm not sure if it's referring to data management issues. So maybe I'll try to, from the top of my head, talk about sort of the things that we've already been thinking about and which are planned. So one of the things is that because we have the traceability of a lot of these variables, we want to add code modules that automatically do what I would refer to as sanity checks, so that a date is actually in a date format, and there are much more sophisticated checks that you can do for other variables, but that this basically gets injected into a process, into an analysis process, as a quality control gate. Again, this is more on the builder side. For the validation engine side, especially these data issues and tracking data issues and capturing them is actually something that I'm very passionate about, because I had a lot of these problems as anyone who does data analysis. So one example is when you have 0 observations in a data set. Of course, if you create a new empty data set, then that's not a problem. So that's usually a note in a log. But of course, if you have that, let's say after you do join between 2 data sets that have 200 and 550 observations before the join, then probably something went wrong. There are other cases where certain kinds of join, given what the original data sets had in terms of numbers of observations, indicate a problem. So for example, if you do a join on a variable that has or join on variables that is unique in one data set, but it's not unique in the other one, then of course you get a crazy big number. So there are many of these checks that we can do just based on logs, which without seeing any detailed data tell you about the data and how it's analyzed in the code. And then there are a lot of other things about just code robustness and data analysis. So what let's say one quick example would be sort of my favorite one would be if you have certain kinds of code constructs like if-else clauses. If you don't have a terminating else clause that sort of catches all things that you don't expect and gives you an error, or maybe handles that special case in some meaningful form, those are things that we can really easily automatically, and also then ultimately once we get to the builder, in real time scan for and give warnings for. There are also things which I really also like, is that with this code analysis, we can sometimes predict that if new data comes in, certain issues will be triggered that you can't see in the log yet because they simply haven't occurred yet. But of course, as clinical trials happen, more data comes in and you have sort of more issues. So this robustness of handling data that you just haven't seen yet, that's going to be a focus in the log analysis and then ultimately in the building engine. I hope that sort of addresses it, Sri.
And maybe one question for Sunil, which some people in the audience may be wondering, if this is something they'd like to use for their own studies, how would anyone go about doing that within their organization? Is that a case of speaking to their management? Because introducing any new software is a fairly, there's standards teams involved. Curious if you could share your thoughts a little bit, Sunil, given your experience in change management, especially in larger organizations.
Yeah, definitely. I think organizations, they obviously have a lot of responsibilities, and they have many studies they have to manage, and strict timelines. Introducing something new definitely can be challenging, but it's not impossible. I think recognizing the potential benefit, seeing the impact that it can directly have within your team and within your company helps a long way. Seeing and defining the scope of how that can be introduced into the company within the team. So maybe there's a specific pilot project, or maybe there's a legacy study. There may be something that is maybe a lower priority, or something that low risk that could be introduced and using this type of technology. And I think getting the hands-on experience, seeing a demo is one thing, and then having questions, getting input from your team, how it can best utilized, what specific features do you like the most, and then fine-tuning that and getting the experience, testing it out, seeing the impact will really go a long way to prove the case that this does in fact can replace and enhance what you have been doing before. So I think there's definitely a case in the path that organizations should seriously look at to move forward to introduce this tool.
Excellent. Well, gentlemen, and every single one of you who've joined the webinar, I'm glad to say that almost everyone stuck till the end. So very pleased to see that. If you've got questions that you may have later, again, join our community forum. We are still setting things up on Outverse, but this is the best place to get in touch with us. And yeah, the video is going to be on YouTube. Stay tuned for more stuff that we're going to put out there. There's going to be a lot more releases coming, some of which we'll try to release for free, others which will be closed source, but we'll try to do things as best as possible with the community. So stay tuned with that. And any final words, Henning or Sunil?
From me, it's just a big thank you guys for spending your time with us, and I hope to see you in the community.
Yep. Thank you. Look forward to seeing you all soon. Bye-bye.
Excellent. So good evening, good morning, and good afternoon, wherever you're dialing in from. I hope to see you the next time. Cheers, everyone. Bye-bye.
Bye.